Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Athir Zalal.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone and welcome back. Are you ready to level up your Kubernetes game? Today we are diving into the nitty-gritty of monitoring and managing Amazon EKS clusters. Get ready for some practical tips and tools to keep your clusters running smoothly in the cloud. So let's start. Preventive and continuous maintenance is core to keeping an environment in optimal condition while keeping an eye on the performance. What tools does Amazon EKS provide for monitoring and managing Kubernetes clusters?
EKS provides a lot of tools that will allow you to monitor and ultimately manage the EKS environment and the applications within it. These tools can either be Kubernetes tools, they can be third-party tools, or AWS tools. There is a lot of integration with different types of analytical, monitoring, logging, dashboarding tools that you can use. I would like to mention specifically the fact that EKS itself already has inbuilt a number of metrics and logging mechanisms that will show you this in the AWS console out of the box without you doing anything. These will show you things related to the cluster health rather than the containers or the software within that cluster. But then there is integration, very good integration, and you can do it quite fast with CloudWatch. CloudWatch is a separate service in AWS which allows you to do logging as well as metrics, dashboards, and they have a lot of other sub-features which would be interesting in this case as well. So CloudWatch would be the first tool that I would definitely recommend. There is a sub-service in CloudWatch called Container Insights, which if you use it, it gives you pre-built dashboards of EKS cluster health, but also the containers and the software running inside EKS. You can have a lot deeper insight into that environment. There are also a couple of other services from AWS, like Managed Service for Prometheus, AMP, right? So this is basically Prometheus, which is a very common metrics logging system that is managed by AWS. So you don't have to install Prometheus and manage and scale and secure Prometheus yourself, but rather have a managed version of that, which easily integrates with EKS. There is also Managed Grafana, which is a dashboarding tool. It visualizes those metrics from CloudWatch or Prometheus. Again, there is the managed version of this called the Amazon Managed Grafana, which helps you bring up a Grafana cluster in a very easy and fast manner and integrate it with EKS quickly. That's just scratching the surface. Lots of other third-party tools as well. You can obviously install these tools yourself on the EKS cluster itself or on separate clusters. But yes, those would be the main ones for monitoring and management.
So, at the center of every discussion of monitoring AWS infrastructure and services, there is CloudWatch. How does Amazon EKS integrate with AWS CloudWatch and other monitoring solutions?
Yes, so this is a follow-up to the other question. Ultimately, if we had to go deeper on how EKS integrates with CloudWatch, you can look at CloudWatch as different APIs. So CloudWatch has the logging API, which allows text-based logs with timestamps. And these logs can be related to the cluster itself, but can also be related to the containers, or the software within those containers can be easily using this CloudWatch Logs API to send information to CloudWatch. And those logs are ultimately shown in the CloudWatch dashboards. You can then view them in other tools or get them from the API itself as well. It helps you have a centralized logging system. CloudWatch has CloudWatch Metrics as well, which is a different API. And again, there is already out-of-the-box integration for the cluster health, the metrics there, those data points which are numeric data points in specific time with a specific timestamps, and those have out-of-the-box integration in terms of cluster health. Again, you can send your own metrics, your own numeric time-stamped metrics towards CloudWatch metrics API from inside the containers and then viewing those through the CloudWatch dashboard. There are other ways as well, like CloudWatch Container Insights. Each one has its own integration method, but they are very similar to each other. And it always depends whether you want to monitor just the cluster health, the Kubernetes EKS cluster health, or the pods and software from in there. Obviously, our suggestion is to always have both and have a good plan going in of what you want to monitor. Don't forget about Grafana and Prometheus, as we said before. Whether these are installed by yourself or they are managed from AWS, ultimately integrating these with your software is quite easy. Finally, third-party integrations. There are literally thousands of these, but good mentions would be Datadog, Splunk, and many, many others. Each one will have its own integration methodology. Once you have a plan of what you want to monitor and which tools to use, also taking in consideration the pricing of each tool, then it's a matter of integrating based on that tool's best practices.
There are hundreds of points to be monitored on any running service, but not everything is critical to be on a dashboard. What are some common metrics and indicators to monitor an Amazon EKS environment?
All right, good question. Basically, what we suggest is to always have a plan and split the different metrics in two. First of all, you have the cluster metrics, the cluster health. So you have things like CPU utilization, memory utilization, the status of each pod, the status of nodes that are the worker nodes that are running those pods. So that is your cluster health. And whatever tool you're using to monitor that, those metrics will indicate reliability issues and downtimes that are very important to handle immediately. Then you can, apart from cluster health, you can also have application performance metrics. These are more custom for your application, but things like request latencies. How long do requests take to come back from the application itself? The number of errors, the error rates. Maybe split those based on different types of errors, the importance of those errors. And obviously the resource consumption, how much memory CPU is each pod taking, and you can see how many times a container restarts. So there are lots of things that you can monitor, and whatever your tool you're using ultimately help you troubleshoot and find patterns to improve the reliability, the performance, security of your cluster and its software that it's running.
Whether on-prem or in the cloud, there is no 100% trouble-proof system, and one day there will definitely be an issue somewhere. Can you explain the process of troubleshooting and debugging issues in an Amazon EKS cluster?
Like in every other technology out there, monitoring is essential to be able to then troubleshoot and debug. So the faster and the easier it is to do this monitoring, the faster your troubleshooting and debugging is going to be. So if, let's say, you're using CloudWatch logs and CloudWatch metrics, so it's a matter of going into the dashboards and finding patterns, finding specific issues if you know exactly when the issue happened. Maybe you have your own tools that you integrate with CloudWatch or external third-party tools that do this. Today, with AI and machine learning, there are tools out there that use machine learning technologies to bring out the right information without getting overwhelmed in terms of logs and metrics. So these are all things that can help you. You can leverage normal Kubernetes tools, which you would use in any Kubernetes environment. Things like kubectl logs, for example, to show the logs from inside, to inspect the logs inside the containers. It's still very important to ship those logs out to a centralized tool like CloudWatch, because ultimately that container could go down, and you might, depending on the setup, you might lose those logs. You can use things like X-Ray, AWS X-Ray, which is a tracing tool allowing you to view logs on a larger high-level scale where you are seeing all the different data points passing from different microservices, and then you can dig deeper into specific problems. So the options are really infinite, if you want to see it like that. There are lots and lots of options. It will depend on that plan that you create of what you want to monitor and how fast you want to be able to troubleshoot, have processes around that, and then decide on a tool to implement those processes. Whatever you choose, that plan is going to be essential. So I will keep on repeating that, because in IT in general, monitoring is essential, troubleshooting is essential, and having a plan for that is the first step to best practices.
Lastly, who get to do what? Despite sounding simple, is a make it or break it topic on the security level. What are the recommended strategies for managing security and access control in Amazon EKS?
Okay, so security and access control in EKS is obviously a very important topic, just like using other services like EC2 and S3 and ECS. In EKS is the same thing, right? It's all about IAM. IAM, the global AWS service, which allows you to create users, groups, policies, and roles. We have other episodes that explain what these are. And ultimately, those roles will give access to your pods, which are running your software inside that cluster, and the resources around that. So what can your pods do? What access does the software from inside the pods have to the outside, to S3, to EC2, to anything else on the internet? So what access do your users from outside EKS, what access do they have on the software? What access do your administrators have? So the least privilege access is what you need to aim for here. Not too much, not too little, enough permissions to do its work efficiently, but ultimately not more than that. Those least privilege access roles can be used very easily with EKS. Don't forget the network layer. So before we're speaking about roles, which is more of an application layer, kind of security access and control. Now we can also talk about layer 3 and layer 4, which is the network policies. EKS Kubernetes itself has, depending on what setup you're using, has good network policies that allow you to define the permissions, the network permissions of the pods themselves. So what can the pods talk to, and on which ports, on which IP or DNS addresses, etc. Here the suggestion is to isolate as much as possible. Use Kubernetes namespaces, use Kubernetes network policy rules to make sure that your pods can only speak to what they should be speaking to. So if a pod should be allowed to speak to a different pod, then allow that, but nothing else. If a pod should be only allowed to speak to external parties, to the incoming requests from the external environment, then make sure that only that is allowed. And lastly, reactive security audits. Going through the security mechanisms that you are using, making sure they are working, testing it. There are, again, automated tools that can help you with this, that can be proactive, not just reactive. But ultimately, make sure that issues are brought to the surface from a security perspective as soon as possible. The longer it takes, the more the issue will become an issue. So these things, roles, network policies, regular audits, and as well making sure that your credentials are not saved inside those pods, but rather you can use the Kubernetes vault mechanism to save your secrets, or you can use things like AWS Secrets Manager to save your credentials. Those are all things that you can do from a security best practice.
And finally, thanks for joining us today in this episode. We hope you picked up some valuable tips for keeping your cluster running smoothly in the cloud. Stay tuned for our final episode, where we will explore the advanced topic and future trends in Amazon EKS. Until then, happy cloud computing! If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.